decimals, and percents, how do they relate together? Right? We've talked about them individually. We spent the most time on fractions, right? But then also we're going to discuss decimals and percents today. We'll have a little bit of work on Thursday, and then on next Tuesday we will be having a short quiz. Alright, so the very first, let's get rid of this, we don't need to see that. Alright, the very first things that we're going to do is we're going to go over this. This was part of the homework from last class. And I ask you to think about this in terms of percentage. What are some things that you notice, right? And then how does it relate to percent? Now, some of us were very astute, we had great observations, and let's go over this together. All right, the first thing that we should notice, though, right, is obviously there are different colors. All right, and then we should notice. So first, no, let's write that down. Right, what do we notice? Right, there are different colors. Right, and they have different proportions. Right, what that means is that not all of the colors take up the same amount of space in the actual square. Okay, and we can actually start to figure that out, how much each space takes up. So how does this relate to percent? Is we can think about how many, let's say, pink spaces squares are there. So for pink squares, we know that there are 5 of them, right? But we got to think about how many actual squares are there. Remember, this isn't a rectangle. This is a rectangle, not a square. It actually takes up 3 spaces. We can do that visually. If I just take my pencil here, we can actually should be able to complete this, right, in order to see what it looks like. We can do that for all of them. So one rectangle, one blue rectangle, is the equivalent of 3 squares. Taking a long time to draw today. Okay. Nope, I'm done. I'm done. No drawing. Okay. So if there's 5 pink squares, and there's a total of, count them out, 1, 2, 3, 4, 5, of 25 squares. Okay? So then we can say that it is, for pink squares, it is going to be 5 over 25. That's my fraction. Alright? Remember, percent, right? Percent means out of 100. So we want to make this 25 out of 100, right? And how do we get from 25 to 100? We have to multiply by 4. So what we're going to do is 5 over 25. If we multiply both numbers by 4, it's going to equal 20 over 100. From that 20 over 100, we can know that 20% then, because 20 over 100, 20 per 100, that means the 20%, right? 20% of all of these are going to be pink squares. So how does this image relate to percent? It's the fact that we should know, by looking at it, what is the percent of each color, right? And you can continue to do that for each of them. Alright, so here we have, let's make this a little bit bigger so we can actually see it. Here we have a box of tea. Alright, what do we notice? What should we notice? Well, some things we should know is that it has 100 tea bags. We should also notice that not all of them are visible, right? Not all of them are present. Okay? So when we want to think of it now as percent, is once again, if we have a total and we have an amount, we can write that as numerator and your denominator. Okay, so if you count out all of them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. I got roughly 28. Now you might have a different number, right? And that's okay. But let's say there's 28 out of 100 tea bags left, right? So once again, that means 28 per 100. So 28% of the tea bags remain, right? Conversely, that means 72% are gone. The reason I know 72% are gone is because I have 28% left. right? So if 28% left is left, then 72 out of the 100 have already been used up. All right, so it's looking at images and starting to think of, well, what does this represent, right? What is this? How does this relate to percent? And speaking of relating, we kind of have done this already, but then really, what is the relationship? Fractions, decimals, and percents are three different ways to describe parts of one whole, right? A fraction, as we saw in here, right? A fraction can be represented as a percent, right? It can also be represented as a decimal, and vice versa. Right? They can all be represented as themselves. So here we have an image. This is it's 100 squares, and of that 100 squares, 25 are shaded in, right? So 25 of the 100 are shaded in. That's why we can represent it this way. But not only can we represent it as a fraction, we can also represent it as a percent and a decimal, right? These values are the exact same. You can use percent to describe any part of one whole. So that's what they do, right? Percent is part of one whole, and one whole is always going to be 100%. So what we're going to do quickly is we're going to go through and just look at how can we actually start to convert from this, from a fraction to a decimal, from a decimal to a percent, and etc. Right, so conversion. The first one, from percents to decimal, all you have to do, right, is divide by 100 and remove the percent. It's really easy, right? So if we're going from percent to decimal, if we have 75%, we divide by 100, which means we move over two decimal places, because remember, there's always an invisible little decimal at the end of all numbers. You move it over 2, and you drop the percent, and you're going to get 0.75. All right? So divide by 100, move the decimal 2 points to the left. That's from percents to decimal. And you can take your time. You can work through some problems if you want. You don't have to just keep going at my pace. From decimal then to percent, you're going to multiply by 100 and add a percent sign, right? It's the exact opposite. So if you have a decimal like 0.125, you're going to multiply it by 100, which means you're moving to the right, and then you're going to add on a percent sign. So that's going to be moving over to the right. It's going to be 12.5%. From a fraction to a decimal, the easiest way is to divide the top number by the bottom number. Divide the numerator by the denominator. So if you have 2 out of 5, right, as a fraction, you're going to divide that 2, the numerator, by the 5. That's going to give you 0.4. All right? These are just our conversion rules. From a decimal to a fraction, you're going to write the decimal as a fraction with the numerator being its value. What that means is, so if you have a decimal of 0.75, you're going to write it as a fraction with its value, 75, being its numerator. And the denominator will always start as 100, right? Because if it's percent, right, you always want to aim for 100. It's the easiest to convert between 100. Okay? So then what you're going to do is you're going to then remove the decimal. So notice I'm not putting 0.75 over 100. I'm just putting the 75 over 100, right? So not 0.75 over 100, 75 over 100. Now it's as a fraction. Simplify if necessary. This is where I feel like a lot of people are going to lose some marks. Right? I can reduce this, divide both these numbers by 25. That's going to give me 3 over 4. From a fraction to a percent, you're going to divide the top number by the bottom number and then multiply it by 100 and add a percent sign. So here we have 3/8. Right? First divide the 3 by the 8, the top number by the bottom number. That's going to give our decimal. Right? Then you're going to multiply this decimal by 100 and you're going to add a percent sign. So we have our 0.375. We're going to multiply that by 100, so it's going to be 37.5. Add a percent, 37.5%. And your last one, from percentage to fractions. First convert to a decimal, divide by 100, and then use the steps for converting to a fraction. So basically, if you're converting 80% to a fraction, you start with 80%, write it as a decimal, right? All you have to do is divide it by 100, so you're moving over 2 to the left. Put this value over 100 as we did just right here, right? The 80 over 100, and then simplify. All right, so work through these at your own pace. If you get confused by any of that, maybe work on some of the practice problems, the extra practice at the end of this. Okay, so for example, here we have an example straight from the textbook. Right, a fish tank contains rainbow fish, and goldfish. So this is our rainbow fish, this is our goldfish. The ratio of rainbow fish to goldfish in a tank is 1 to 4. What percent of the fish are rainbow fish? Right? So if the ratio of rainbow fish to goldfish is 1 to 4, that means there's a total of 5 fish, and only one of them is a rainbow fish. So 1 out of 5. So we know how to write it down as a fraction. We divide the top number by the bottom number. That's going to give us 0.20%. Now from that decimal, right, we multiply by 100 and we add a percent sign, and that's how we're converting it. Okay, once again, you can go through all of these in order to see how that happens. But what it's showing you is the relationship and how this and this and this and this all have the same value. 20% of the fish are rainbow fish. Let's do this one together, all right? Last example. So what we have here is we have an image of different shapes. And what we're going to do is we're going to find the fraction of squares, right? So if we count them, 1, 2, 3, 4, 5. There's 5. My math's going to have to change. I wasn't paying attention, right? So 5 out of 10 are going to be squares. The numerator is always going to be the number of squares. Your denominator will be your total shapes. Alright, so 5 out of 10. Again, you have to bear with me. So percent means out of 100, so we need to write an equivalent fraction with hundreds, right? We always want to, in order to get it from now to decimals and to percents, we want to take this fraction that we got from the picture, and we want to make it as close as possible to 100. Luckily, we can multiply them both by 10, and it's going to give us 50 over 100. So if that means out of 100 of these shapes, if we somehow were able to duplicate these perfectly, out of 100 of these shapes, 50 would be squares. Now writing it as a decimal, so 50 out of 100, you're going to divide the numerator, the top number, by the denominator. So 50 divided by 100, you move that over the decimal place over to the left. It's going to be 0.5, right? So remember, move it over to the left. So 0.5 of the shapes on this image are squares. Percents. Again, changing this because I didn't count right, and I know someone's going to call me out on it. Okay? So if 50 over 100, this means 50 out of 100 shapes would be squares. That means if we divide the numerator by the denominator, that's going to be 50% would be squares. I want to see if you can do this for circles and triangles. All right, I want you to see if you can find them in the fractions, the decimals, and the percents for those shapes. Explanation for your assignment. Basically, you're going to make a design. You're going to start with a 10 by 10 grid. All right, so 10 by 10 means there's 10. 1, 2, 3, 4. I'll even write it out. That helps you. 1, 2, 3. Oh, that's 22. 3, 4, 5, 6, 7, 8, 9, and you can't really see that. 10. Right? So 10 and then by 10. So altogether you're going to have 100. You can do this on a Word document, you can do this on a slide, or you can draw it out. Right? You're going to use 4 of these colors. Now the colors, I guess, aren't important if you don't have colors at home. If you're doing it on a computer, then yeah, absolutely you should use those colors. If you don't, you just have to write out again to show me how it represents. The colors can be your choice, but again, you just got to let me know. So at least 7/10 of the squares must be colored. That means of the entire squares, 7/10 must be colored. I mean, you can leave 3 out of 10 or 30% of it blank, but 70% needs to be colored in. At least 4% of the squares must be colored blue. What that means is at least 4%, at least, you can have more, should be, let's see if I can fill these. No, that's probably not going to work. Should be blue. Yeah, right? So at least 44% of the squares must be blue. No more than 8% of the squares can be colored orange. At least 0.5 of the squares must be colored green or red. Right? So this is really what's guiding your design. Besides that, your placement, where it goes, or what it looks like isn't important. It's more about the math. Can you figure out, right, how to incorporate these? So once again, if you're doing it on slide, all you have to do is go up and you find the fill button and you can put in any color you want, right? Try your best to stick, and it's going to work the same on a Word document, right? If you go insert, go to table, go insert table, you go 10, 10 by 10, right? I press insert, and it'll pull up, and then you just have to fill it in the colors. If you're drawing it, just make sure that there's 100 total, and you go 10 by 10. After you fill it in, I want you to describe each color of your design as fractions. Describe each color of your design as a fraction, a decimal, and a percent. What that means is, like for here, for the blue square, let's say I had, just for the sake of consistency, okay, so let's say I drew colored in 10 of them as blue, right? That means 10 out of 100, so that'd be as a fraction, or 10%, that's as a percent, or 0.1. So I'm describing each color of my design as it. You don't have to be as boring as I did here. Maybe you want to have a little bit of blue all over the place. Maybe you want to be a little more artistic to express it. The point, though, is you're showing the relationship between this and you're understanding how to manipulate them. If you still need practice, a little more tangible, click on this link, and there'll be plenty of practice problems you can work through. All right? Let me know if you have any other questions. All we're really focusing on today, though, right, is right here. This triangle. If it's a fraction, how can I write it as a percent or a decimal? And vice versa. All right? Let me know if you have any questions. And yeah, remember, test on Tuesday.